Section 2.3 is about quadratic functions and their zeros. So a quadratic function f is of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. Now, why can a not equal 0? Well, if a was equal to 0, then we'd have a linear function, and that's not quadratic now, is it? The graph of any quadratic function, guys, I have these like earbuds that don't have a cord and they won't stay in my ear and they keep falling on the floor. So I'm sorry. It's a day. So the graph of any quadratic function is a parabola. It has a vertical axis of symmetry. Like a butterfly, you could fold it in half and it will be the same. And its domain is all real numbers. What changes with a quadratic function is its range. And we're going to talk about how to find that in section 2.4. So here are graphs of some different quadratic functions. So when we say we want to find the zeros of a quadratic function, that means we want to find the x-intercepts. We want to find where f of x equals 0, right? We can also call those the solutions. They go by many, many names. So as a parabola, it's a degree 2 equation, meaning it has a second degree. It can have up to 2 solutions. If it has 2 solutions, it's going to cross our x-axis twice. If it has 1 solution, it's going to touch the parabola at one specific point. So that would be something that looks like f of x equals, this would be x minus 1 squared. It could also have no solutions. That would be when it never crosses the x-axis. And this means that solutions are complex, right? We're living in the real world. We can't take the square root of negative numbers. This is the real number line. So if it has complex solutions, that means it doesn't cross the x-axis. A quadratic equation is of the form ax squared plus bx plus c equals 0. This is a quadratic equation. We took the f of x and replaced it with 0. This is the standard form of a quadratic equation, and quadratic equations must be in standard form in order for us to factor them. So first off, let's talk about the zero factor property. So if I have a and b, and those are numbers, and their product is 0, then a equals 0 or b equals 0. Or they could both equal 0, because 0 times 0 equals 0, and 0 times any number also equals 0. So in order to find the zeros, right, or the x-intercepts, the solutions of our quadratic equation, we could take its factors. We have to take its factors, set them equal to 0, and solve. So I have x is negative 6, and 2x equals 3, so x equals 3 halves. These are my x-intercepts, right? This is my zeros. These are my solutions. When x is negative 6, y is 0, and when x is 3 halves, y is 0. So keep that in mind that we're talking about the same thing. There are many different ways to find the zeros of a quadratic function. We're going to talk about factoring, completing the square, using the square root property, and last but not least, probably most well known, the quadratic formula. So let's start out with finding the zeros by factoring. So the first thing you have to do is make sure your quadratic equation is in standard form. So we're going to set, for example, 1, 2x squared plus 3x minus 2 equals 0. Then you have to factor the polynomial. I factor polynomials by finding the factors of AC that add up to B. We want to find the factors of AC that add up to B. So in this case, AC is A times C. That's 2 times negative 2, so I have negative 4, and B is 3. So what are some factors of negative 4 that add up to 3. Well, if I needed to, I could make a little table. Say 4 is negative 2 times 2, negative 1 times 4, negative 4 times 1. Those are all the different possible factors of negative 4. And then I would see which of them add up to 3. Well, that's going to be negative 1 and 4. So what I'm doing then is I'm using those two factors to pull the middle term apart. So I have 2x squared minus x plus 4x minus 2. And it doesn't matter if I did minus x or plus 4x first, I'm going to get the same answer. We set that equal to 0, get some grouping symbols in to factor by grouping. We can factor by grouping when we have 4 terms. So I pull out the greatest common factor of 2x squared and x, that's x. The greatest common factor of 4x and negative 2 is 2. What's inside the parentheses here should look the same. So I pull out the greatest common factors. I get x plus 2 times 2x minus 1 equals 0. And if I FOILed this back out, you'd see I'd get back to our original quadratic function. Now I use the zero factor property. So I'm going to have to take up so much room. Please ignore this function for now. X plus 2 equals 0, and 2x minus 1 equals 0. So I get x equals negative 2, and x equals 1/2. These are my two zeros, right? These are the x-intercepts. If I want to, I can check my answers in my original polynomial. So if we have 3 terms, I always want to find the factors of AC that add up to B. If there are no factors of AC that add up to B, we're going to need to use a different method that we'll be talking about as this section goes on. We just want to have all these different ways of factoring quadratic functions in our toolbox.